I wanted a custom insert for my Starlink Mini that would fit in a Milwaukee Packout 8430. The catch was I didn't want to model the whole thing manually from scratch, so I used AI. It wasn't perfect on first try. In fact, it took me like 16 iterations. It made the design process way faster. The goal was pretty simple. I needed the Starlink Mini to sit securely in the Packout, with room for some accessories like, cables and a little pull mount. And I needed it to clear the molded center divider. To be honest, the divider ended up being one of the biggest constraints. The dish pocket had to sit high enough so the bottom did not crash into the center section, but low enough that everything still fit under the lid. I started with a few reference models, Packout side and center STL files, plus the Starlink Mini model. Instead of manually redrawing every shape, I used AI to inspect the STL files, measure their bounds, especially on the outside where all the shapes were for the Packout. And then I had AI help write OpenScad code to combine the Packout footprint with the custom dish pocket. The useful part was not just asking AI to make a model. The useful part was using it like a second set of hands. I would say things like, make this one in shallower, keep the dish pull relief, add chamfers to the insert openings, split into printable sections. The AI helped update the OpenScad files, run exports. That let me move through a lot of iterations without manually editing every number. This was definitely not a one-shot success. Some versions were bad. Another version created a weird void where I needed solid material. And one version had this little extra lip above the chamfer that would have printed very bad. The important part was that I could measure the problem, describe it clearly in a prompt, and then have it adjust the OpenScad script. For example, I measured the dish insert and realized I needed a 26mm pocket depth. Once that was corrected, the dish sat the way I wanted. I needed the Starlink Mini to drop in cleanly, and I wanted chamfer topped edges so it was easier to insert and remove. The final version was a 26mm dish insert depth. Also, I committed a crime, and you can say that, using a DeWalt multi-tool to cut out the center divider in the Packout. I also learned a tip that for a bunch with the razor blade, just keep scoring. There's a nice line that you can score. It actually will just snap off cleanly, and then you won't have the problem that I had. So the final centerpiece, used the bottom geometry from the real center STL that I borrowed. Only a couple millimeters tall, and then a bridge plate on the top to fill the gap between the left and right. Because the full insert is too large to print in one piece, is still split into sections because I only have a 220 by 220 by 220 millimeter print plate. There is a left front, left back, right front, right back, plus the center's front and back pieces. It took a lot of version 16 to be exact, but AI made the process a little faster than doing every measurement. I think this is where AI is useful for makers. Not as a magic button, but once you get a nice workflow going, I think it can save a good amount of time. If you want to see more projects like this, I'll keep testing AI-assisted CAD design and on some other real-world parts. If you have any ideas for the Packout or camping or trailer gear, I'd love to implement it. Just let me know. I'm also going to have my OpenScript files, some of the STL files over on my GitHub, and then I might upload them to Make-A-World or Thingiverse. Check the links down below. If you use files I had or use the script I had or make anything else for your Packout, yeah, please let me know, tag me. I would love to see it. So thanks for watching, and see you in the next one.